230 quid to tax the van. Robin, hello, I didn't see you there. Should I play with some Duff LED floodlights? Yeah, why not? Okay, first up we have here a 20 watt British General floodlight. Now I didn't supply this, so I don't know what the history of the thing is, but I was called out to change it because it wasn't working. You can see there's not a lot to it. It hasn't got a PIR sensor, just a pre-wired lead. So we'll come back to that in a moment. Right, what I actually did replace it with was this 10 watt Avantec light, because they said that the old one, when it was working, was too bright, so we went for a 10 watt. This is interesting. This has actually been in stock probably for about 2.5 years. It's one of those things that just sort of fell to the bottom of the shelf, and I forgot I had it. So when a job came up where it was required, I thought that would be ideal, and I could finally use it. And it was in place for about a week before the people called back to say, "Yeah, nice new floodlight you installed isn't working." So great, a warranty replacement was required. So I went out there and changed it, and I've taken it away. And what we're going to do is we're going to open up both of these today and see if we can see what's gone wrong with them. Note straight away that you can see that there's no discoloration of the LED dies. A lot of the times when an LED light fails, you'll see a black spot on the die, which indicates something's gone bang somewhere. That's not the case here. So I'm guessing that it may be something else, internal fuse, driver. We'll have a look and see what we can see. So let's start with the big fella first. Just whip the back on it off it and take a look and see what's going on. There is a screw missing out of this, so I don't know if that's related to the history of the thing, or whether moisture has got into somewhere where it shouldn't, or anything like that. We'll undo the three out of there. Alright, well, there's no sign of ingress by moisture, and in fact that is an IP67 driver anyway, so water's not going to do any damage to that in theory. IP68 of course being full submersion, and we're nowhere near anything like that here. No sign of anything going bang or burnt, or no loose connections, nothing degraded. You can see these pre-wired things annoy the hell out of me. I mean, halogen floodlights were never pre-wired, so I don't know why they think that the LED ones are somehow advantageous to have this ½ metre or whatever bit of cable hanging off the thing. It just means you've got to junction it externally, so it's a bloody pain. Incidentally, the Time Guard models are not pre-wired, and they do come with the connector block on the back in a waterproof box, just like the old halogen floodlights. I've got a page on my website about that. Well worth a read, of course, I would say that. So let's have a look then and see what we can see. This power supply says it is DC 30 to 36 volts, which is interesting. It's 600 milliamps, and it's rated at 20 watts. It's got there on the ID plate. 30 to 36 volts, eh? So we're talking, yeah, we should be talking about 600 milliamps at 20 watts. With my bit of Ohm's law in my head there. So what we're going to do is we're just going to cut these around where they're stuck on here. And basically, I'm just going to take that annoying earth wire out as well. We'll just see if we can figure out whether it's the driver or the LED itself that's failed. As far as I know, there's nothing inside this section I'm working on now other than the LED die. There's no other electronics or anything like that that could fail, but we will perhaps take a look into there a little bit later. Let's see if we can get to the ends of this. Just chop them off. What we can do, we can test the driver under no load just to see if there's a voltage coming out of it, and then we can stick a voltage into the LED die and see what it does. Right, we'll do the driver test first. I'm just going to go and get my voltmeter. Okay, There's the voltmeter, an old school Sinclair model. Not GS38 compliant leads, but we're just testing a bit of DC here, so let's not worry about that now. We know that it's supposed to be around 30 to 36 volts, and this not ever been calibrated voltmeter is recording 42 volts. 42, the answer to life, the universe, and indeed everything. Of course, this, I don't know, you can see that better there. This driver is not under load, so it may well be a little higher than the nameplate suggests anyway, but that does suggest that the driver might be alright actually, because it is producing a voltage somewhere near where it should do. So let's stitch the voltmeter, grab the power supply and see if we can get anything out of that LED die. Okay, here we go. Right, so let's we'll crank up the voltage actually as we go along and see what happens. Let's switch it on. So I've got it set to, in fact let's whack it right up as far as it will go in terms of its current output. At the moment it's taking 0 milliamps because I haven't actually connected the probes, but we'll put them on now. And we've got it on just under 12 volts at the moment. Nothing occurring there. Let's start cranking it up. Well, we should be getting something at 34 volts. And we're certainly getting nothing at all, so it would indicate perhaps that the die has failed here. We'll take a closer look and see if that's the case. Okay, well, as expected, there's no clever electronics inside there. Those two wires do just go back to the die itself. Again, no dark spots, no indication anything's fizzled out. I have tried the power supply directly on these contact points with no success. So something's gone wrong with this. Let's see if there's anything to see on the back. Bit of heatsink grease there, perhaps not enough, maybe that's the problem, perhaps it's overheated through a lack of grease. It's not had perhaps an effective, the metal hasn't been in contact enough to act as an effective heatsink. I don't know though, but like I said, there's nothing to see on there, but chances are if I were to acquire a new 20 watt die and put that in, then this thing could be brought back to life perhaps, although I doubt I'll bother. So let's clear that away and we'll have a look at what's going on with the 10 watt unit. Okie dokie, let's have a look inside this cheap bit of garbage and see if we've got the same sort of thing again. Interesting that these two haven't got PIRs, because often on some of the LED floodlight failures I've seen it's the PIR that goes rather than anything else. And in fact I've actually resurrected a couple by removing the PIRs and installing an external one. But these are about as basic as they come. Now we've got it's a little bit different inside this one. Instead of a sealed LED driver, we have a PCB. Let's have a little closer look at that. It's no sign offhand of any broken connections. Capacitors haven't burst. Can't see anything that's immediately showing signs of having gone pop. There is a fuse there actually. Let's do a little continuity check on that. Yeah, fuse is okay. Obviously something's gone wrong somewhere. So what we'll do is we'll plug this in and we'll see if we get a DC voltage out. It looks like the DC out is on this side. So I'll just get this plugged in and set up the voltmeter again, and we'll see what we can see there. Right, okay, we are plugged in. We should have 230 volts going inside into the PCB. let's just have a look at what we've got coming out. So this is still set to DC volts on the 100 volt range, and if I just touch the outputs there, I'm getting nothing. Yep, nothing at all. So let's just unplug that. So I guess here we've got either a duff driver or that the LED die that it's going to is shorting it out and pulling the output low. So we'll do the same trick again. We'll disconnect the driver from the die and we'll see what they do individually. Where's my little magnet thing gone? Here we go. This is my old Palm Pre desktop charger here, but it's great for storing your screws on. Right, let's cut the cables. Okay, what we'll do, we'll just leave that sort of right in there. Just try and get it away from the metal. Make it live and check it again for an output. So let's plug her in. So if the die is faulty and is pulling down the output, we should see something here now. No, we've still got nothing. Okay, let's unplug that and give the die a test. Now I've got no data on this driver and chip, so I don't know what voltage is supposed to be going in there, but I'm guessing for a 10 watt die it's probably going to be about 12 volts. We'll be on the safe side, we'll turn it down a little bit. We'll limit the current as well. Let's just see what happens here. Oh, that. Oh, yeah. I don't know if you can see that. That is coming. Oh, that's very bright. It is coming on. Coming on at 9.8 volts there. Current's jumping around a bit. I think it's just because I'm not holding the connections on very well. But yeah, we're talking just under an amp there at 9.8 volts DC, so that LED die is okay. So we definitely have the opposite problem to the last one here. We've got a good die and a bad driver. So I can change the driver in this one potentially and resurrect it. Let's just have a closer look at the back of that driver. See if I can see, again, no sign of anything having gone bang. I can certainly test out a few of those components and see if I can trace which one's got faulty, if I can be asked. Chances are I can't. It's probably just as easy to simply stick a new driver in series there. I don't know, there's not a lot of room to play with in there. So it may not be a goer anyway, but there you go, a couple of different faults and a couple of crappy LED floodlights. But again, if you're buying an LED floodlight, the best option in my opinion is to go for a time guard for various reasons, as stated in the review on my website. I do apologise, I seem to have interrupted myself mid-sentence there. I was going to extol the virtues of the time guard LED floodlight, but I'll tell you what, I think I'll pick one up from Edmondson's this week and do another exciting video review on that to come in the next few days. One thing I do want to show you though, that Avantec light, the one with the good die and the bad driver, I have managed to resurrect that, interestingly enough, using a old laptop power supply rated at 9.5 volts and at 2.5 amps, so plenty of juice for that. And I'm not going to sell it on to anybody, of course, but I have put it here, fitted a switch onto it, and it now lights up my desk of demonstration. So when I come to do my time card review, hopefully I'll have some better lighting in my videos thanks to my my 10-watt flood that's now lighting up the desk. The switch there was in the place where the old flex used to go in, and I've drilled a hole in the back for the cable to go through for the power supply. So all's well that ends well with that thing. At least it gets a new lease of life for as long as the die lasts. And yes, I'll have a play with the time guard later this week, so stay tuned for that one. Much excitement guaranteed. So I guarantee.